This is question 15, SAT Practice Test 2, No Calculator section. The expression 5x minus 2 over x plus 3 is equivalent to which of the following? And then they have 4 answer choices. This is not the grid-ins. 3 ways to do this. I'll go through, let me go through the more complicated ways first, so then a very simple way to do it finally. 5x minus 2 divided by x plus 3. That is division. We're dividing 5x minus 2 by x plus 3. And notice answer choices C and D have 5 minus 2 over x plus 3, 5 minus 17 over x plus 3. When you do division, sometimes something can have a remainder, and the remainder is added or subtracted, depending on if it's positive or negative, and some number over the thing you were originally dividing by. So notice C and D have that. They're both over x plus 3, which is what it was originally being divided by. So those are remainders. Well, if they're remainders, let's try to do division and see what the remainder comes out to. It's important to remember that if the remainder comes out to 0, that means that x plus 3 is a factor of 5x minus 2. But if the remainder does not come out to 0, in the case of C or D, then x plus 3 is not a factor of 5x minus 2. That could be important to other SAT math questions. A and B, they don't look right when you're doing division this way because they're not divided by the original denominator, x plus 3. So those probably aren't the answer, but we'll check them. We'll be able to check every one of the answer choices when we do this division. There are 2 ways to do division when you have polynomials, something with an x. The first way is the more complicated way. It's called polynomial long division. I thought I was writing, but I was erasing. Okay, 5x minus 2 divided by x plus 3. When you perform polynomial long division, it is very important that you include every power of x, from whatever the highest power is in the numerator down to just a constant. Now in this one, we have x to the first power, 5x to the first power, minus a constant. So nothing has been skipped, but I'm just going to give you an example. Let's say it was 5x cubed plus x minus 2. Notice that there's no x squared, there's no x to the second power. So when you perform polynomial long division on this one, you'd have to put a placeholder for x squared. So this would be 5x cubed plus 0x squared plus x minus 2. So whenever you're doing polynomial long division, and once we're done doing this, I'll also show synthetic division. Always account for every power of x from whatever the greatest power is of the numerator. In this case, in the case of the actual question, it's only 1. But in the case of this example, it's 3, down to just the constant. Let me delete this because that was just an example. If you look up a video, you can go to Khan Academy and look up polynomial long division or synthetic division. They will make that point. Now we're doing polynomial long division. So look at the first term there. How many times does x, what do I have to multiply x by to turn it into 5x? Well, I have to multiply that by 5. So 5x, and then 5 times 3 is 15. This is going to be a very short one. And then, of course, I'm subtracting them. When you do long division, you subtract. So 5x minus 5x is 0. Negative 2 minus 15 is negative 17. That means the remainder is this, negative 17 divided by x plus 3. So it's 5 minus 17 over x plus 3. That's answer choice D. Now, this one, I could also do polynomial long division. And I'm deleting it by undoing. So if you need to see what was there, just go back in the video. I have to clear space for myself to do synthetic division. In synthetic division, as long as whatever it is we're dividing by is just x plus 3 or x plus 8 or x minus 6. In other words, it has to look like this, x plus or minus a. It's a very simple factor. In other words, we cannot be dividing by x squared plus 7x plus 2 or x to the x cubed minus 6. It's got to look like x plus or minus a. Well, this one does, x plus 3. So we take that number when our factor, the thing we're dividing by, is just x plus or minus a, and we change the sign of the number. So this is x, this is minus 3. That's what we do when we do polynomial synthetic division. And then we write down whatever the numbers are in front of each term, each power of x and the constant. So in this case, I just write 5 and minus 2. Again, you can look up synthetic division to find out more about this. You'll find videos or even just text explanations. I believe in the SAT Practice Test 2 answers, the explanations, College Board provided long division. But you can do synthetic division too. So now whatever this first number is, bring it down like that, and then multiply that negative 3 times 5, that's negative 15. And then you add those. That's negative 17. And whatever the last one comes out to, that's the remainder. So the answer to this is 5 minus 17. And the remainder is always written as over the original thing that was in the denominator, or dividing by. So 5 minus 17 over x plus 3. Again, answer choice D. The book showed long division. That was synthetic division. That's a little bit quicker than long division when what's dividing is x plus or minus a, x plus or minus some constant. Now, the third way to do this, and the simplest way of all, if you're not sure about how to do polynomial long division, if you're not sure how to do synthetic division, and this method goes along anytime on the SAT math section, if you can't really think of something else to do, you can either plug in answer choices or plug in some number for x. If you plug in your own number, make sure you check it against every answer choice. Plug in the number into the original expression or equation and see what that equals. And then plug in your number to each answer choice and find ones that don't work. The ones that don't work, eliminate them. Sometimes the first number you pick won't work with 3 of them and only the 4th one will remain, and then you have the answer. Sometimes the first number you pick will end up working with more than one answer choice. In that case, pick another number and check it against those 2 answer choices. Let's say there were 2 that your first number worked with, and keep doing that until you eliminate all but one answer choice. Well, let's try something very simple. Now, we have to remember in this one, we can't choose x equals negative 3. Cannot choose that. Because if we choose x equals negative 3, the denominator, negative 3 plus 3, is going to be 0. We cannot have division by 0. It is not done. Let's choose something very simple. X equals 1. The original expression, if we decided that x equals 1, is 5 times 1 minus 2 divided by 1 plus 3. That's 5 minus 2, which is 3, divided by 4. So now, whichever answer choice is correct, and remember, with the first number we pick, more than one may turn out to match this, but we want to find answer choices that, when we plug in x equal 1, equal 3/4. Whichever ones don't, we are going to eliminate. Hopefully, we've picked a number that will eliminate 3 out of the 4 answer choices. It's always wise to pick a very simple number first, because who knows, maybe it will work with more than one answer choice, but it's simple, so it's quick. 5 minus 2 over 3, there's nowhere to plug in x there. Now, some people would say, hey, that means we can just ignore choice A and B because there's nowhere to plug x in. Well, who knows? It might come out to equal 3/4 no matter what, and then we'd have to accept it as working with x equal 1. Well, 5 minus 2 over 3 equals 3 over 3, which equals 1. A is eliminated. Gone. We will never have to look at it again. 5 minus 2/3. If we want to subtract a fraction from a whole number, we must find common denominators, Common denominator is 3. 5 is really like 5 over 1. 1 goes into 3 3 times. 3 times 5 is 15. So this is 15 thirds minus 2 thirds, which equals to 13 thirds, which clearly is not 3/4. B, gone. Now let's try in C. 5 minus 2 over 1 plus 3. That's equal to 5 minus 2/4, which is 5 minus 1/2. That's 4.5. That is not equal to 3/4. So C is out. At this point, I'm pretty certain the answer is D. If you wanted to, you could put a question mark. Sometimes it's hard to get writing up there. It minimizes the page or minimizes the screen. Put a question mark by the number. Put a question mark by the answer choice to let yourself know, hey, if I'm done with all of the other questions and I have time, I'm going to check D. But at this point, I've checked A, B, and C, eliminated all 3 of them. I'm pretty certain the answer is D. Let's check it now because we're learning how to do this kind of question. This is going to be 5 minus, remember I'm plugging in 1, 17 over 1 plus 3. That's 5 minus 17/4. Well, that's like 5 ones minus 17/4. I need a common denominator. It's 4. 1 goes into 4 times. 4 times 5 is 20. So this is 20/4 minus 17/4, which equals 3/4. So there, I verified that the answer is D, or found that the answer is D. So without doing polynomial division, without doing synthetic division, you can find the answer to this question. I recommend that you learn how to do polynomial division and learn how to do synthetic division. You can find videos on Khan Academy, on YouTube, all over the place, or if you just type in a search, polynomial long division, synthetic division, you can find videos or just text explanations. The SAT Practice Test 2 answers for this question, number 15 in the No Calculator, shows an explanation of how to perform polynomial long division. I just went through, at least for this question, how to perform both polynomial long division and synthetic division. So try to learn those. But if you don't, you have a technique for when you don't know the math. Plug in a number you make up, and when you do that, check it against every answer choice. If you can eliminate all but one, then that one is the answer. If you can't eliminate all but one, let's say you only eliminate 2, then come up with a different number. A lot of times if in the expression there's an absolute value or there's x squared, then sometimes a number you pick originally will work with more than one answer choice. So then pick something that's further away from 0, or pick something that's negative if you've already used a positive number, because absolute values can flip a sign. If x is -1, then absolute value of -1 is 1. So that tells us, well, maybe we want to try a different sign. And x squared the same way. -1 squared is equal to 1. So we flipped the sign again. So that's in case the first number you plug in works with more than one answer choice. Maybe try something negative or further away from 0 or closer to 0. But in this one, it was pretty easy. The first number we picked, x equal 1, and a very simple number we picked came out with the right number. Let's try something else here, because you say, well, what if I picked a different number? I don't believe that this is that easy. Okay, let's pick a different number. And let's try a number here that a lot of people would not pick, because they say, well, you can't divide by 0. So I'm going to pick x equals 0. I really can't get rid of those crossouts, but let's just remember that these are now not crossed out, because now we're picking a new number and we're just pretending we haven't found the answer. We're just first working this. All right, let's try x equals 0. 0 plus 3 isn't 0, it's 3. So the denominator would not be 0. So this would be 5 times 0 minus 2 divided by 0 plus 3. 5 times 0 is 0. So that on top is -2 and on the bottom is 3. So -2/3. All right, let's try this. 5 minus 2 is 3 over 3. That's 1. Nope. A is now eliminated. 5 minus 2/3. That equals 15/3 minus 2/3. That's 13/3. Nope. B is eliminated. Hold on. I just minimized my screen again. This is 5 minus 2 over 0 plus 3. That's 5 minus 2/3. Well, that's the same as B. It's going to be 13/3 again, which is wrong. Now, again, I know C is the answer, or at least I'm pretty sure if my work was accurate. So I could put a question mark there and a question mark next to the question number, pick D, and then if I have time, go back and check it. However, we're working on it, so we're going to make time right now. 5 minus 17 over 0 plus 3, which is just 3. 5 minus 17/3, that's 25/3 minus, oh, not 25/3. Look, we've made a mistake. I made a mistake when I was using my common denominator. The common denominator is 3. This is like 5 over 1. 1 goes into 3 3 times. 3 times 5 is 15. 15/3 minus 17/3. That equals minus 2/3. And that matches. So we verify that D is the answer. This time we plugged in x equals 0. So you can plug in a number. When you plug in a number, check it against every answer choice. So once again, polynomial long division. How do I know I had to do this? Because I see that there's one polynomial divided by another, and I also see two answer choices that have what looks like a remainder. So there's polynomial long division. Because I have x, a very simple polynomial that's doing the dividing, x plus or minus a, x plus 3, I can also work this with synthetic division. And then when all else fails, always you have a number of tricks in your bag of tricks, and one of them is just make up a number and plug it in and make sure it follows whatever guidelines are in the question. In this case, the only guideline it has to follow is that it can't make the denominator equal to 0, because division by 0 cannot do it. There's your answer on this one, D. And in this case, plugging in a number is the quickest way to find the answer. Number 15, SAT Practice Test 2, No Calculator section.